Hello everybody and welcome to the first video in our proportional reasoning series. Today we're going to look at rates. What is a rate? A rate is a comparison of two amounts measured in different units. So some examples. I could say 360 kilometers for every 3 hours. So we're comparing these two different amounts in different units. One in kilometers, one in hours. Another one, you could say you type 240 words every 8 minutes. Okay, so those are some examples of rates. What is a unit rate? A unit rate is a rate in which the second quantity or value is 1. So, for example, you could say that gas costs 86 cents per liter. And that'd be per 1 liter. Let me write that again. Per 1 liter. You could say something like orange juice from a certain brand costs 15 cents per 1 milliliter. All right, that one maybe isn't as realistic, but that's how they would look. You can transform a basic rate into a unit rate through reducing or division. So if we go back to our original examples, if I say 360 kilometers, and I wrote it with that slash, that's usually how you write rates, with that slash. 360 kilometers in 3 hours, I could reduce that. I can divide both the top and bottom by 3. I'd get 120 kilometers for every 1 hour. And then I could express it as 120 kilometers per hour. So you didn't know it, but you are using unit rates every time you're telling someone your speed. If you're going 50 kilometers, that's actually 50 kilometers per hour. So your speedometer is actually set up in unit rates. So there's that one. If we take our 240 words, and we said it took us 8 minutes to type those 240 words, we could then reduce that one as well. This one we divided by 8, I'd get 30 words for every 1 minute. And then I could express it in this rate form, 30 words per minute. All right, so often we'll start with a basic rate and then transform it to a unit rate. Let's look at some examples. Tony drove for 510 kilometers and used 46.7 liters of gas. What is his car's fuel economy? Answer to the nearest hundredth. Okay, so when they're talking about the fuel economy, they're really asking for a unit rate. So they'll often tell, if you go to a dealership, the stickers will often say how many kilometers something will go in 1 liter, or how many liters of gas would be used in 1 kilometer, but some sort of unit rate. So what we'll do is we'll just set this up, and again, we could go kilometers per liter or liters per kilometer. It doesn't really matter. They're both the same idea, just expressed different ways. So if I go 510 kilometers over 46.7 liters, now that's a basic. This is our basic rate. We're going to transform that into a unit rate. So like I did previously, I just divided them, I reduced them. The fractions were really easy to reduce. This one, there won't be anything common. So what I can just simply do is divide top by bottom, and I'd get 10.92 kilometers for every 1 liter. So then I'd express that as 10.92 kilometers per liter. And again, if you wanted to express that as liters per kilometer, so how many liters would be used in every 1 kilometer, you absolutely could, and that would be valid as well. Example 2. A 2-liter carton of chocolate milk costs $4.26. What is the unit rate? Okay, so we're going to see the cost of milk. So now, again, you have a decision. Do you want to go how many liters per $1, or do you want to go how many dollars 1 liter costs? And that's what I kind of like this one more. I think that one makes more sense. Again, either one would work. So I'm going to say it costs $4.26 for 2 liters. And then I divide 4.26 by 2. and I'd end up getting $2.13 for 1 liter, and I can express that then in my rate form, my unit rate form, $2.13 per liter. Okay, so now let's kind of progress a little bit. Hopefully now you understand how to make a unit rate. Now we'll just kind of start using, seeing kind of the benefit of a unit rate. So a 5 kilogram bag of potatoes costs $8.15. A 10-pound bag of potatoes costs $7.10, which is the better buy for the consumer. So a nice use of unit rates is simply comparing things. So if you're comparing things and there's different amounts, and because there's different amounts, there's different values attributed to it, you can create a unit rate to kind of compare apples to apples, or in this case, potatoes to potatoes. I know that's a bad joke. Anyway, move on. Okay, so the first one, let's kind of write down what we got. I've got 5 kilograms, and it's costing $8.15. The second one, I have 10 pounds, and that's costing $7.10. So the issue here is that I've got kilograms in one and pounds in the other. So I've got to actually convert these into the same units. So seeing we're Canadian, we might as well change this into metric from the imperial. I'll just kind of do that over here. Let's pick a color. Green. Green's a beautiful color. So there's a conversion between kilograms and pounds, and 1 kilogram is approximately, I should go wavy lines, approximately 2.2 pounds. All right, so from here then we can use a proportion, or you can simply multiply to convert this from kilograms to pounds. But what we do is we'll set up a proportion. You'd go 1 kilogram over 2 pounds is equivalent to, we're not sure how many kilograms, over 10 pounds. So this is called a proportion. It's going to tell you, it'll tell you how many kilograms is in 10 pounds. Once I have this, now I cross multiply. So I'm going to go 1 times 10, x times 2.2. Now notice I didn't bring the units with me. So the units are only there to help you set up the proportion. A couple things about a proportion. The left side is always some sort of math fact, so that's this conversion rate or conversion expression here. And whatever you put on top on the first one, so I put kilograms on top of the first one, I've got to put then kilograms on top in the second one as well. So that's why those units are there, just to help me organize. Anyway, back to solving. Then I have 10 equals 2.2x. You want to get the x by itself, so I divide 2.2. I'm going to write my x on the left side, because that's the proper way I should do that. This works out to 4.5. So then I know that 10 pounds is approximately 4.5 kilograms. So I can update this. 4.5 kilograms is now costing me $7.10. So still, it's not, I'm not sure, because there's a 5 kilogram bag and there's a 4.5 kilogram bag. So they're not the same amount. So this is where the unit rate will help us out. Okay, get my pen working. So we'll do the first unit rate. So again, you can go kilograms per pound or money per kilogram. I kind of like that. So I'm going to go dollars on top, because to me it makes sense to go something's $2 per kilogram or whatever it is. And I'm going to divide it by 5. When I do that, I get $1.63 over 1 kilogram. This is a kilogram, filling in some of my units, sorry. So the way I can express that with the unit rate is $1.63 per kilogram. So I know for every kilogram it's cost me $1.63. Second one, I'll perform the same type of calculation. $7.10 on top, divided by 4.5 kilograms. Do that division, you'll get $1.58 over 1 kilogram. So again, I'm dividing the top into the bottom. My bad, I'm dividing the bottom into the top. I'm going $7.10 divided by 4.5. And then I can write that $1.58 per kilogram. And then we just check to see which is the cheaper. Well, it says which is a better buy. So the assumption I'm making is that it's the cheaper buy. So that would be this right here, $1.58 per kilogram. So there's a use of unit rates. we took these different amounts, 5 kilograms and 4.5 kilograms, and then we're able to determine what is the better deal. Okay, so let's look at one more example, and this example again is going to highlight just the benefit of a unit rate or the usefulness. And really, unit rates, like for just everyday things, guys, that you would identify with, like shopping, unit rates are really nice for shopping because you can determine what are better deals. So here's another example. Orange juice is sold in 1.5 liter cartons and 250 milliliter boxes. A 1.5 liter carton sells for $3.75, and 10 250 milliliter boxes sell for $7.39. Which size costs less per milliliter? Sorry. Now, you might be thinking right away the 1.5 liter, it's cheaper, so you'd go with that. But if you're getting less juice, it might not be cheaper. Like you might have to buy, 2 or 3 of those to kind of make up the difference. So let's check this out. Let's go to unit rates. All right. So again, I'm just gonna summarize. I like working in blue. I'm just gonna summarize this first of all before I get going. So I have 1.5 liters, and you don't have to do this. I just kind of like doing this, getting some of the fluff out of the way. So I know that it's 1.5 liters, and it cost me $3.75. The other one, I have 10 250 milliliter boxes at $7.39. So the first thing I want to do is like the 10 250 milliliter boxes. Really, I just want to see this as one buy. So how many milliliters would I get? Well, if I multiply that together, then I'm really just getting 2,500 milliliters. And again, that's cost me $7.39. So I'll just put a line. Sorry. Come on, pen. All right, pen doesn't want to. Whoa, that was kind of crazy. Not sure what happened there, everybody. Hopefully that recorded okay. My laptop just went funny, but you didn't miss anything if it did cut out. I just updated that second equation. Now, if it's in milliliters, we got to have the same units. So I got to go back to the top one here, and you need to remember that 1 liter is equivalent to 1,000 milliliters. So that would mean that this is really 1,500 milliliters. So 1.5 liters is really 1,500 milliliters, and that's costing now $3.75, like I said. So in these unit rates, you want to make sure both unit rates are using the same units, or it won't be much of a comparison. Again, we want apples to apples, or oranges to oranges. I couldn't resist it. Sorry. Okay, back to this. Okay, so let's actually find these unit rates. So you can go either milliliters per dollar or a certain amount of money per milliliter. I'm always kind of doing money per something, so I'm going to go $3.75 divided by 1,500 milliliters, and that's going to work out to something that's really cheap. It works out to 0.0025 milliliters. I'm sorry. That is 0.0025 cents, I guess, right, per milliliter. The second one is $7.39 over 2,500 milliliters. Divide top by bottom. I end up getting 0.0030 milliliters. So you can, per milliliter. Man, I did that twice in a row. Anyway, you can see that these are kind of smaller amounts, and I mean, that's less than a cent per milliliter. So that might seem strange, but I can still kind of compare them. And then when I compare them, I can see that this is the cheaper way to go. If you really wanted to, though, like I said, if that doesn't make sense to you, then just flip the unit rate around. So I'll just set it up that way. When I do my division, I would then get 400 milliliters per $1. And then the other one would be 2,500 milliliters. And that is over 7.39, so $7.39. And that's going to work out to 338, and I'll say 0.3 milliliters for every $1. Gosh, I made a mistake again. That's kind of crazy how I did that. Anyway, now the best buy here, you'd want the most milliliters per dollar. So again, you can see that the numbers are different, but the same unit rate would win out. So it doesn't matter which way you compare them. You'd get the same answer regardless. All right, so that is rates and unit rates, and hopefully saw a use for unit rates. If it didn't make sense, talk to your teacher or get talking to me. Have a great night, everybody.